So part B of the question, part B of that question, we are told to calculate the following. So number B, find the instant at which the acceleration is 0. Find the instant at which the acceleration is 0. Now we need to note very well that when the acceleration is 0, it means that the gradient is 0. When acceleration is 0, it means that the gradient for the velocity time graph is 0. The gradient is 0, and the gradient is dv all over dt is equal to 0. So we need to get the dv dt, we equate to 0 so that we can get the instant, the time at which the acceleration is 0. So we have the dv dt, we have it here, which is 10 minus 2t. So our dv all over dt is equal to 10 minus 2t. So our acceleration is 0 when the gradient function is 0. So when it is at 0, when acceleration is 0, when a is equal to 0, we have 10 minus 2t equal to 0. So we find the value of t. So we'll have negative 2t is equal to 0 minus 10. So negative 2t is equal to negative 10. We divide by negative 2 by negative 2. And therefore time will be equal to 5 seconds. So this is the instant at which the acceleration of this particle is equal to 0. So that instant is when time is equal to 5 seconds. When time is equal to 5 seconds. So another example, we can do an example 3. Number 3. Example 3 for the application of differentiation in calculation of acceleration. We are given a particle moves in a straight line. A particle moves in a straight line such that its velocity v meters per second after t seconds is given by the following equation. V is equal to 4 plus 8t minus t squared. So the question is asking find the acceleration at t equal to 10 seconds. At t equal to 10 seconds. So I want us to find the acceleration in this question. A particle moves in a straight line such that its velocity v after t seconds is given by this equation. Find the acceleration at t equal to 10 seconds. Again, in this we want to calculate the acceleration. And we have said when we want to calculate the acceleration, we find the dv all over the dt. We differentiate this equation with respect to t. And therefore, our acceleration, therefore, will be equal to dv all over dt. That is, we differentiate 4, we get 0, plus, we have 1 here, we have 8t, 1 minus 1, then minus 2 times 1, that is 2t squared minus 1. So we have our acceleration as 8 minus 2t. That is the acceleration. And therefore, we now want to get the acceleration at this instant when t is 10 seconds. And therefore, when t is equal to 10 seconds, so we are going to equate this, we are going to equate acceleration to this, where t we substitute with 10 seconds. So our a will be 8 minus 2 times 10, which will be 8 minus 20, that is negative 12 meters per square second. So our acceleration is negative 12 meters per square seconds, meaning that when you have acceleration as negative, when the acceleration is negative, when a is negative, it is referred to as deceleration. It is referred to as deceleration or retardation. When you calculate and find that the acceleration is negative, it simply means that this body is slowing down. Maybe it was moving at a velocity of 10, then it moves down to a velocity, for example, of 2 meters per second. Then it means that the acceleration will be negative, and therefore it is referred to as deceleration or retardation. So our retardation in this question, or our deceleration, which is our retardation in this question, therefore, will be equal to 12 meters per square seconds. The negative shows that it is a deceleration, and therefore the deceleration is 12 meters per square seconds.